second example. Let's see, let's change this back to... Okay, we finished up that second example yesterday. So we're going to go to the next example number 3. So for this example, we have to solve a triangle. We must find all sides and measures of the angle. So last night I told you guys you didn't really actually have to solve the whole triangle. You could just find one of the missing sides or angles there. So this time I want us to solve the triangle, meaning we have to find the measure of all the angles and all of the sides. So for this problem, we've got a 70-degree angle for A, and we've got 26 is our side C, 25 is our side B. So right here, be careful because we have an angle and two sides, and that angle is not between the two sides. So we have angle, side, side. So we've got to watch out. We must check for ambiguous case. And we only did one of those, and it wasn't ambiguous, so I'll remind you of that again here in a minute. So we have 70 degrees and 25. Those are across from each other, so I'm going to use sine of 70 over 25 is going to equal, which angle do I have to find? I have to find C. I cannot find B because I don't know the side across from B right now. So I'm going to have sine of C over 26. Okay. Richard, what do we do to solve that equation? Cross multiply? Yes, that's right. Alright, so 25 times sine C is going to equal 26 times sine 70. And we're solving for that C right there. So Richard, what's the next thing we would have to do to try to get that C by itself? Divide by 25, perfect. So that gives us sine C equals, let's just go ahead and put that into the calculator, which I must have shut down. So we'll have 26 sine 70 divided by 25. So we get 0.977 something. I'm not so worried about writing the whole thing down, but make sure that you keep that number in your calculator. Don't use the rounded version. And then, how do we get rid of sine? Inverse of sine. So that sine inverse, we're taking sine inverse of both sides. It'll cancel out over here, and sine inverse here. And so we will do sine inverse of, and then you can press second and the negative key, and it just puts the answer there so you don't have to retype it. And so we get C equals 77.763. degrees. Alright, so that's good, except this is an ambiguous case. So basically, anytime you find yourself having to do sine inverse, you need to check for ambiguous case, because if you find yourself having to do sine inverse to find the angle, then you had an angle side-side problem, even if you didn't remember to check for it. So if you have to do sine inverse, you need to check for the ambiguous case, because I know that 77.763 is one of the answers, but on that unit circle for sine, there might be another answer over there in that second quadrant that would also work. So to check for ambiguous case, going to do 180 minus the 77.763 degrees. So if we do 180 minus this answer, we get 102.237. Okay, so the first one that you get will always work. The second one, we're going to check, could this angle right here be 102.237? Is that okay? I mean, I know it doesn't look like it's 102.237, but this is not necessarily drawn to scale. So this is 102, this is 70. B would be like 7 point something, right? This could work. Remember on the one that we did yesterday, when we had that ambiguous case, it was 120 and 137. 120 and 137 cannot be angles of a triangle because the angles have to add up to 180 degrees. So this number was way too big. But this number is not too big. This number, whenever we add it with the other angles, less than 180 degrees. So what we have here is called the ambiguous case. So given the measurements that we have, there are two triangles that are possible. So whenever you have an ambiguous case, whenever I see them, I always am sad about it because ambiguous case problems are going to be twice the work of regular problems, especially if they're asking you to solve the triangle. So C can equal 77.763, but C also equals 102.237 degrees. So it could equal either one of those. So if you're asked to solve the triangle, you're going to have to solve the triangle one way and then solve the triangle the other way. So you'll have two sets of possible answers. So it's twice as much work, which is annoying. But we can do it. So let's start with that 77.763. So let's just pretend that that is the angle. So if C equals 77.763, then B is pretty easy to find. Right here on the side. Not in this case because our angles are not equal to each other. So they only match like they did in that problem that I was trying to do and messed up with crazy numbers. They only match if you have an isosceles triangle where two of your angles are equal to each other. So in this case, we will not have that. So we'll just do 180.
Like if you have 70 and 80.
Right. So like if this was 70 and they told us this was 70, then we would know that was 25. But only if those angles are equal to each other, which they're not here. So for this, we've got to find B. So we do 180 minus 70 minus, actually, let's do this. I'm going to go back and do this with me. Do you guys know how to store a value on the calculator? If I showed, okay. So if you don't know how to store a value on the calculator, follow along. We had to do that 26 sine 70 divided by 25. And then we did sine inverse of that. So I'm going to store this value because I'm going to have to use it a few times. And that way I can just type C instead of using the rounded value. So to store a value, you're going to have the value that you need right here. The store key is right above the on button. And then I'm going to call it C since that's the side, so it helps me remember. You could name it anything. So now anytime you type C, you're actually typing 77.76329.809. So it's good to avoid rounding there. Plus it's easier to type here. So if I'm going to solve, I found that this angle here, no, I didn't find it yet, did I? For B, I've got to do 180 minus 70 minus, and see, I can just type C for that 77.763. So B is 32.237. And I'm going to store as B. So now if I need B, I can use that letter instead of using the rounded value. And so I need to find side B. I guess side B is all I've got to find, right? So to find side B, I'm going to use law of sines. I'm going to say sine of that 32.237 over B equals, you technically can use either set of these, A or C. I always go for A because it was given in the problem and it's not been rounded, so you know it's right. So it equals sine of 70 over 25. And so you'll cross multiply B sine 70 equals 25 sine 32.237 all over, alright, not all over. Then we'll divide by sine of 70, divide by sine of 70. So for B, we'll have 25. And I'm going to type sine of, that was angle B, so sine of B divided by sine of 70. That way I don't have to round, and so I'll get 14.191. So what we have here is we've got one set of answers. So one set of answers is that angle C is 77.763, angle B is 32.237, and side B is 14.191. And you're only halfway done because that's one set of answers, but C also could be 102.237. So in my calculator, I'm going to do 180 minus C, which is right now stored as 77.763. So that gives me the exact value for the other possible C. And so now I'm going to store this as C. It'll replace that other C that I had there. So now C is 102.236. So I've got to go back and do everything I did here, but with this number instead. So I'd have to do 180 minus 7 minus C, not 7, 7D. Okay, and that'll give me 7.7632. I'm going to go ahead and store that as angle B, 7.763. Okay, so then I'd have to set up sine of 7.763 over side B is going to equal sine of 70 over 25. So you're doing the exact same thing you did right here, except you're changing that 32 to the 7. You'll cross multiply B sine B sine 70 equals 25 sine of 7.763 divide by sine 70. And so B equals, what do we get here? 25 sine, oh wait, 25 sine of B And so we've got two sets of answers. We have the first set that's highlighted in yellow there. We also have C could equal 102.237, B could equal 7.763, and little b can equal 3.594. Alright, questions? This is what happens when you have the ambiguous case. You've got two sets of answers. So this would be an ambiguous case. On any other problem, like on that last one that we did, on this problem, when we got our angle R, or our angle Q, and we tried to check for ambiguous case, and the angle that we found would not work. So since it did not work, we just used the answer that we got from the calculator. It is only whenever the angle that you get actually works that you'll have these two separate sets of answers here. And when you have those two separate sets, that's your ambiguous case. So like if this happened in real life, if you went out and took these measurements and you were solving to figure out, you measured off some land or whatever you had here, then you would have to go back and take another measurement because it could be either one of these. Or sometimes they'll be far enough off, like if you were measuring a piece of land and you knew what it looked like, sort of, you would know, well, it has to be this one. Because angle B was not a little tiny sliver of an angle or something. But okay. I almost skipped 4. Let's do 5. 4, there's nothing difficult about 4. I just feel like you've already done some homework with this last night. You don't need that one extra problem there. If you had me for Math 2 and I taught you guys how to do law of sines and cosines, we went and did the same problem. This chimney, I had you guys go out here to that chimney that's back there between the band and the gym, and you can't measure to the base of that chimney to do regular trig because there's a fence around it. Except for one group one year who just found Miss Brown and got her to unlock the fence for them. They were clever there, but you can't measure to the base of the fence. So what happens is you've got this chimney and around it there is this fence. So if you're out here measuring, we need some longer legs, don't we? Really long-legged person. So in a strange posture there, but as you're measuring, normally if we could measure all the way to the base over here, then we would not have to do law of sines. We could just make us a right triangle and solve the triangle. But in this case, you cannot measure to the base. So this is what they decide to do. They measure the angle of elevation to the chimney to be 56 degrees. And because it doesn't tell us, like whenever we did the problem, we had to know like the height of the eye because we did not lay on the ground to take the measurement. Because it doesn't tell us an eye height here, let's just assume they measured from the ground. Assume that information is irrelevant. And then they backed up. Person has really short legs. I cannot draw a very good stick figure today. So they backed up and they took another measurement. He almost looks like his pants have fell down there. So, and they back up 2 meters. So this distance right here is 2 meters, and this angle here is 54 degrees. Okay. So what we're going to have to do is we're going to have to look at this big triangle we have here. This triangle. Because we cannot solve the right triangle over here yet, because all we know is one angle. In order to do trig, regular trig, you've got to have an angle and a side, or 2 sides, or an angle and a side, or 2 sides. And we only have an angle. That's all we have over here. So what we've got to do first is we're going to have to find one of these 2 sides, the red side or the side right here. It really does not matter which one you find. I just usually do this outside side right here. So let's find that side. So I've got this angle right here is 54. I don't know this angle inside of the triangle, but I could find it pretty easily. How could I find that angle? Subtract it from 180, and when I subtract it from 180, I'm going to get an angle of, let's see, 124, right there. And then so now, since I've got 2 angles, I can find the third angle of this triangle very easily, and it's going to be 2 degrees. So obviously my picture's not quite drawn to scale here. So if we look at that big triangle, we could set up our law of sines. We'd have sine of 2 degrees over 2 meters equals, and then if I want to find x, I'm going to use sine of 124 over x. And so we're just going to solve for that x. We'll cross multiply. We got x sine 2 equals 2 sine 124, and I'll divide both sides by sine 2. So x equals 2 sine 124 divided by sine of 2. And we get 47.510. And it might be a good idea here to store that as our x, just in case we need it again, and we don't have it, because we're not done. Okay, so this side right here is 47.510 meters. Okay, questions so far? Now, that's helpful because if I look at this big triangle here, that is a right triangle. And in that big triangle now, I know that this angle right here would be a 90-degree angle. I know this angle right here is 54 degrees, and then I just found that this is 47.510. Okay, so you can use law of sines, and some kids do, but this is regular trig. So remember, some old hippie caught a high tripping on acid. So we want to know this side. This is the height of the chimney. So that side would be our opposite side. And then this side is the hypotenuse. Which trig function do we use for opposite and hypotenuse? The sine. So we could say sine of 54 degrees is going to equal opposite, which is just h, over 47.510. And then what do we do to solve that? Get the h by itself. Just multiply both sides by 47.510. And so our h is going to equal, we'll take this answer here and do sine 54 times that x. And so we get 38.436. 38. Meters. Okay. Questions? All right. So, your assignment is going to be, I wrote it down over here, a couple things. All right. So, page 324. We got to do one more thing though. 18 through 24. And I'm going to give you a word problem worksheet. And actually, let me look at that worksheet real quick. So I have to tell you which ones you can do. Okay. On the word problem worksheet, there are 5 problems that you can do right now. Okay. Some of the word problems are going to be law of cosine problems. So what I want you to do is I want you to read through the problems and sketch a picture for the problem, and then I want you to solve the ones that you can solve. So for example, if I sketched a picture and I ended up with something like this, 8, 25 degrees, and 9. Okay. If I have this, am I going to be able to use law of sines? I'll have A, B, C. So if I tried to, it'd be sine 25 over C equals sine A over 8. So I got 2 variables there, so I can't do anything with it. And if I tried to solve, for a different side, I'd end up with 2 variables no matter how I set it up. So if you have 2 sides and an angle in between, then that's going to be law of cosines. We got to learn how to do that on Monday. If you have all the sides and no angles, that's also law of cosines. We got to learn how to do that on Monday. So there are 5 problems there that you can solve, either using law of sines or possibly a couple of them might just use like regular right triangle trig. So there are 5 problems there that you can solve. So I want you to look through for the ones that you can do there. So there should be 5 that you can do of those. I'm not going to tell you which ones because part of practice solving it is figuring out which one to use. So I'm not going to tell you which ones, but we do need to do number 18 together because 18, I did not do a problem like this in the notes. And there's an issue with it. So for 18, they tell you A is 6, B is 8, and capital A is 150 degrees. A, 6, B, 8, C. So for this one, you do have angle side, so you're going to need to check for ambiguous case. This is the only time I'm going to let you turn in your paper with ASS written all over it on half the problems and not get yourself in trouble. So angle side, here we got to watch out for that. I'm going to put myself a note there. So to solve this problem, I would do sine of 150 over 6. And then it's going to equal sine of B over 8. So I would cross multiply and I would get 6 sine B equals 8 sine of 150. And so I would have to divide both sides by 6. So I would get sine of B equals, let's do that in the calculator, 8 sine 150 divided by 6. So I get hold on. I set everything up right. 8 times. So let me check my mode. I'm in degree mode. 8 sine 150. I've done something wrong. Oh, okay. No, it's still not giving me what I want though. What have I done? Because I can take inverse sine of 0.6. Because the answer to this is supposed to be that it doesn't work, but this is going to work. AB, that's 8. 150. 8 times sine 150. I am in degree mode. When does this not work? I've done this one before. Because you have 0.6 repeating, and then you do sine inverse of 0.6 repeating, which is going to give you a number, and it shouldn't. Well, I guess we have to do it this way. Okay, so this is not the best one to do. So we get 0.6 repeating, and we do sine inverse. I've done this one before, but I don't remember this happening before. So we get like 41.810. Okay, here's the question. We do have to check for ambiguous cases, but before we even check for ambiguous case, 41.810, is that going to work? That adds up to 190. So this one is none. Although it's none, normally when we get none, we get it a different way. So I'm going to show you another problem. We'll do a couple.
So it's not ambiguous.
This one just has no answer at all. Okay, so whoever took these measurements of this triangle was mistaken, because if you have an obtuse angle in a triangle, it has to be the biggest triangle, right? So this 150 has to be the biggest triangle of the three angles. And the biggest angle has to be across from the biggest side. But is your biggest angle across from the biggest side here? It is not. 8 is your biggest side, but that's not your biggest angle. So when this happens, somebody has taken the wrong measurements, which they're doing on purpose here because they want you to see that happens. The way this usually works, though, is more like this. Let me see. Well, there's one I didn't assign to you. I can show you real quick. Let me just show you another one real quick so you can see what usually happens. Like, let's say I have angle A is 76 degrees, side A is 5, side B, this is A, side B is 20 here. So if I were solving this, I would do sine of 76 over 5 equals sine of B over 20. So I would get 5 sine B equals 20 sine 76. I divide by 5. So I'd get sine B equals, and I do 20 sine 76 divided by 5. So I would get sine B equals, this is usually what happens, 3.88 something here. Okay, so when I try to do sine inverse of 3.88, I get an error for this. That's normally what happens when it's 9. So we set everything up correctly here. So when you try to do sine inverse and you get an error, the reason we get an error here, sine is opposites over hypotenuse. What do we know about the hypotenuse? Longest side. Sine can never be bigger than 1 because you're taking the opposite side and dividing it by the hypotenuse, which is bigger than whatever the opposite side was. So sine is always sine of B. Quit doing that. Sine of B must be less than or equal to 1. It is not here, so that one would be none. There's no triangle that meets that requirement. We could have realized that, well, not necessarily, but it kind of looks like that because 76 is a fairly large angle, and it's across from 5. B is across from 20, so it doesn't look quite right. But if you do sine inverse and you get that error, then that tells you there's no triangle that exists that has those sides. Okay, I guess I've done 18 before, but I really don't remember doing 18. 18 just doesn't work when you plug it back in. It doesn't give you an error, but it doesn't work when you plug it back in. So I guess we should be checking those as well. Okay. All right, questions? so you got a little while. I'm going to give you that other worksheet. So on the worksheet, you can only do here. I'll give you a hint. I'll give you a hint so that you're not working on it forever. I'll tell you a couple of them that you got to do. Okay. So on that word problem worksheet, let me look at the answers real quick so I can tell you the right ones. I'll tell you that there are 5 problems you can do. One of them is definitely number 1. And another one is number 7. So you try to find 3 more that you can do. Okay. Any of them, like, for example, I'll rule one more out for you, like, number 3 says Todd, Dwayne, and Hunter are camping in their tents. If the distance between Todd and Dwayne is 153, the distance between Todd and Hunter is 201, and the distance between Dwayne and Hunter is 175, what is the angle between Dwayne, Hunter, and Todd? Does that one give you any angles at all? It is all sides. Have we learned a way we can find the answer with all sides? We cannot. So 3 is not one that you can do, so you can skip over that. So you know you can do 1, you know you can do 7, find 3 more that you can do.